In our last lesson, we looked at the scientific method and noted the importance of representing and analyzing data. Keeping detailed, accurate records is an important part of the scientific method. Data includes facts, figures, and other evidence gathered through observations. Oftentimes, a visual tool such as a chart, table, or graph is used to represent the data collected. In this lesson, we will be looking at different ways data can be represented, as well as how you can understand and interpret information that may be presented to you in a chart, table, or graph. Let's say in a given experiment, 5 new groups of 25 seedlings, all 2 to 3 centimeters tall, were allowed to grow for 3 months, each group at a different humidity level. All of the groups were kept at constant temperature and received the same amount of sunlight exposure each day. The scientists then created a table in order to collect and record their observations. All visual representations should be clearly labeled, concise, and well organized. The title and label should be clearly identified. Think about what would be a good title for this experiment. The scientists are studying the relationship between humidity levels and plant growth. Therefore, an appropriate title would be Effects of Different Humidity Levels on Plant Growth. Your data table should list the independent variable in one column and the dependent variable in a separate column. Reminder, the independent variable is the variable that the scientists are testing and are purposefully manipulating between each setup. In this experiment, the independent variable is the percent humidity. It is seen in the first column. Dependent variables are measured and changes depending on the independent variable. So plant growth is the dependent variable. It depends on the humidity level in this experiment. From this table, we can also see that plant growth was measured by average length and width. From this table, we can also easily identify the control group versus the experimental groups. The control group receives no variable being tested. Therefore, the group of seedlings exposed to 0% humidity would be the control group. The experimental groups, on the other hand, would be all other groups of seedlings exposed to 15 to 75% humidity. Note that the control group is different from a controlled variable. Controlled variables are factors that are held constant among all setups. So in this experiment, some controlled variables are the temperature at which all of the plants are held at and the amount of sunlight in which they receive. Tables can be used to create a graph. Graphs help you understand and use the data. There are many different types of graphs. A bar graph is useful in showing similarities and differences between data sets. It presents categorical data with heights proportional to values they represent. In graphs, the title, axis labels, and scale should all be identified. Note that this graph is titled School Supplies Students Use. Based off of the title, we can infer that this data will compare different school supplies and the number of each school supply used in a given population. The scale is used to compare numerical values between data sets, and in this case is numbered 0 to 10. The x-axis of your graph represents the independent variable, while the y-axis of your graph represents the dependent variable. In Figure 1, the x-axis is labeled type of school supply, and the y-axis is labeled number of school supplies. This is because the number of school supplies depends on the type of school supply we are looking at. Well-organized graphs allow for easier interpretation. Based off of this figure, we can see that pencils were most used and pens were least used in a given student population. A line graph is useful in representing data that changes over time. It is helpful for identifying increases or decreases in data and can help in identifying relationships or trends between variables. Note that the title, axis labels, and scale again are all identified. Note that this graph is titled Percentage of Total Music Sales by Method. Based off of the title, we can infer that this data will compare different methods of selling music from 2011 to 2018. The scale is used to compare numerical values between data sets, and in this case is numbered from 0 to 60%. Again, the x-axis of your graph represents the independent variable, while the y-axis of your graph represents the dependent variable. The x-axis is labeled year and the y-axis is labeled percentage. This is because the percentage of total music sales depend on the year we're looking at. Notice a key is also included in this line graph, so that the amount of music sales by method, streams, downloads, or CDs purchased can be easily compared. A scatter plot is useful in showing the relationship between two variables. It is helpful to show us how one variable is affected by another. Note that the title, axis, labels, and scale again are all identified. This scatter plot is titled Relationship between Study Time in Hours and Main Grade. The x-axis is labeled Study Time in Hours and the y-axis is labeled Main Grade and is measured in percentages. The main grade is dependent on the amount of study time. The relationship between the two variables is known as their correlation. From this scatter plot, we can see that there is a correlation between study time and grade. As study time increases, grade increases as well. Data analysis is the process of interpreting the meaning of data we have collected and organized. This process involves looking for patterns, similarities, differences, trends, and other relationships, and thinking about what these patterns might mean. Data analysis is an extremely important tool and can be translated to everyday life. For example, this is used in the business world. Data analysis allows companies to provide decision-making insight into the following key areas: predict customer trends and behaviors, analyze, interpret, and deliver data in meaningful ways, increase business productivity, and drive effective decision-making. You will be asked to represent and analyze data in your future classes. In addition, the ACT Science test contains passages that fall into three main categories, one of those categories being data representation. The data representation format will ask you to understand and interpret information presented to you in graphs, tables, and charts. While you may not be familiar with the exact concept that the passage is discussing, the good news is that all of the information you need to answer the questions will be located in the data. All we want to do is have a fairly strong grasp of what is being presented and how to interpret the data. Let's look at a few tips so that we can make sense of it all. First, let's locate the title and labels. The title reveals to us what the data is representing. Then find out what the axis, columns, rows, etc. represent. What is on the x-axis? What is on the y-axis? How can this help you identify what the independent variable is and what the dependent variable is? What is the label for each row and column in a table? What are the individual parts of the diagram? Feel free to underline and circle any important information or write out notes on the side of your visual. Anything that helps you interpret the data is useful. Then you want to make note of the units of measurement and scale. If heat is a variable, is it in Fahrenheit or Celsius? Is the mass in grams, kilograms, or pounds? Look at the scale and make sure you understand what the data is measuring. Check to see if there are any little asterisks at the bottom of the table or graph. They can offer some important supplemental information, so make sure you read those too. Finally, note the overall trends in the data. Once you know the labels and the units of measurement of each item in the table or graph, it is important to spend time thinking critically about the data. For example, if column A is increasing, what is column B doing? Does it also increase or does it decrease? Does it decrease for a while and then level off? Create your own system of labeling that makes sense for you. You may want to highlight points where the data changes by putting a circle, a triangle, a star. The idea is to notice the changes. The common relationships that we're going to be looking at are direct versus indirect relationships. Direct relationships are when two things change in the same way over time. In a table, if column A increases and column B increases at the same time, we can say that the two are directly related. Let's look at the graph on the left. As weight increases, we see that height increases as well. Therefore, we can say weight and height are directly related. However, let's say we have a table and in column A, the values increase, but in column B, the values decrease. Then we would say that there is an indirect relationship between column A and column B. Let's look at the graph on the right. As quantity purchased increases, the price decreases. Therefore, we can say quantity purchased and price are indirectly related. And that concludes our lesson on data representation and analysis. Hopefully you found this video helpful. Please continue on with the supplemental activities in order to help you gain a better understanding of this concept. I'll see you in the next video. Bye!